Exercise 3.3, problem number 1. Find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficients. Look at the question number 1 here. X square minus 2x minus 8. Now first find the coefficient, write the coefficients of the given polynomial here. Look at here. The value of A is 1 and B is equal to minus 2 and C is equal to minus 8. Okay. Now after that, write the factorization of this one. X square minus 2x minus 8. So now write like this: x square minus 4x plus 2x minus 8. Then take the x common, x into x minus 4 plus take 2 common here, 2 into x minus 4. Now x minus 4 take the common on both the terms. So x minus 4 into x plus 2. Now equate to 0, then you will get the factors of x. X is equal to 4 comma x is equal to 2 minus 2. Okay. Now for the zeros, p of x is equal to 0 here. Then only you will get x is equal to 4 and x is equal to minus 2. These are the zeros of the given polynomial. So p of x is equal to 0 for the zeros of the polynomial. Then x minus 4 equal to 0, then x is equal to 4. That is alpha is equal to 4. And x plus 2 equal to 0, then x is equal to minus 2. Then beta is equal to minus 2. Okay, these are the zeros of the polynomial. To verify with the zeros of the polynomial and then the coefficients, we get the sum of the zeros. Sum of the zeros is equal to alpha plus beta. And the coefficient is minus b by a. Okay. What is the alpha value here? 4. And beta is minus 2. Substitute both. 4 plus minus 2. What is b value here? Minus 2. So minus of minus 2 by, what is a value? A is 1. Okay. So 4 minus 2. Here minus of minus plus 2. So here on left hand side 2 and right hand side 2. So it is verified on LHS and RHS. Both the values are same. Then it is verified. Okay. And product of zeros then. Product of zeros. Alpha into beta equal to C by A. Okay. So now we know the value of alpha, that is 4 into beta is minus 2 equal to, what is C value? C is minus 8 by A is 1. So 4 2s are minus 8. This is minus 2 times. No? So minus 8 equal to, on left right RHS side minus 8. So LHS is equal to RHS. Hence it is proved. So means zeros are verified here and our zeros are 4 comma minus 2. Okay na? Now look at the next problem. Look at the question number 2. 4s square minus 4s plus 1 is the given polynomial, quadratic polynomial. Now split this one. 4s square minus 2s plus 1. Then take the 2s common here in the first two terms. 2s into 2s minus 1 and take minus 1 common here. Then 2s minus 1. Okay. Now for the zeros of the polynomial, for the zeros of the polynomial, p of x equal to 0. For the zeros, p of x is equal to 0. Then, so now from this, just note down here, 2s minus 1 into another is 2s minus 1. Okay. So then 2s minus 1 equal to 0 here, and 2s is equal to 1 s is equal to 1 by 2 for the first term. For the second term, 2s minus 1 equal to 0, then 2s is equal to 1, s is equal to 1 by 2. So these are the zeros, and first zero is alpha, second is beta. So alpha comma beta are 1 by 2 comma 1 by 2. Okay. To verify whether these alpha comma beta 2 are correct or not, if you will get LHS is equal to RHS by substituting in sum of the zeros formula and product of the zeros formula, then these two zeros are correct. Okay, na? Now substitute in sum of the zeros formula. Sum of zeros, that is alpha plus beta equal to minus b by a. Now first write the b value here, the coefficients of this quadratic polynomial. So a is equal to 4, b equal to minus 4, c equal to 1. Now substitute here. Alpha is 1 by 2 plus beta is 1 by 2 equal to my b is minus 4. So minus of minus 4 by a is 4. Okay. So 1 by 2 plus 1 by 2 is 1 plus 1 by 2 equal to, so minus of minus plus 4 by 4. Okay. This is 2 by 2 equal to 4 by 4. This means 2 cancel, 4 cancels, means 1 is equal to 1. So LHS is equal to RHS here. Now write in product of the zeros formula. Product of zeros, that is alpha into beta is equal to c by a. Okay. Alpha is 1 by 2 into beta is 1 by 2 equal to c value is 1 by a is 4. Okay. So 1 by 2 into 1 by 2 is 1 by 4 is equal to 1 by 4. So here product of the zeros is also verified. Hence these are the zeros of the given quadratic polynomial. Now look at the question number 3. Question number 1, bit number 3. Now look at the bit number 3 here. The given is 6x square minus 3 minus 7x. First rearrange in the correct order of the quadratic polynomial. So that is 6x square minus 7x minus 3. Okay. Now write down this 7x into 9x plus 2x like that. Okay. So 6x square minus 9x plus 2x minus 3. Then take 3 common here, 3x common in this, first in the first two terms, 3x into 2x minus 3, and here take plus 1 common and 2x minus 3. Then now take 2x minus 3 common in both the terms, 2x minus 3 into 3x plus 1. For the zeros of the polynomial, p of x is equal to 0. Okay. Then you will get alpha value and beta value. Okay. Now make it as equal to 0. 2x minus 3 equal to 0. Then 2x is equal to 3. X is equal to 3 by 2. That is alpha is equal to 3 by 2. Okay. Na? Now 3x plus 1 equal to 0. Then 3x is equal to minus 1. X is equal to minus 1 by 3. Okay. This is beta value. Beta is equal to minus 1 by 3. To verify whether these two zeros of the polynomial correct or not, substitute in sum of the zeros and product of the zeros formula. Okay, na? First substitute in sum of the zeros formula. Sum of zeros. Sum of the zeros. Okay, that is alpha plus beta. To verify with coefficients, what are the coefficients? Sum of the zeros is equal to minus b by a. Okay. Now what is b value here? First write the coefficients here. A is equal to 6. B is x terms, coefficient of x. That is b is equal to minus 7. And c is equal to what? C is equal to minus 3. Okay. Now substitute in this. Alpha is equal to 3 by 2. So 3 by 2 plus beta is minus 1 by 3. Minus 1 by 3 is equal to b is minus 7. So minus of minus 7 by a is 6. Okay. Now look at here. LCM is 6 here. 3 3 is 6. 3 3 is 9. Minus 2 1 is 2 divided by 2 3 is 6. Okay. Now look at here. Minus into minus is plus. Plus 7 by 6. Here minus 9 minus 2 is 7. So 7 by 6 is equal to 7 by 6. Okay. In sum of the zeros, the coefficients are verified here. And substitute in product of the zeros. Product of zeros is equal to alpha into beta equal to c by a. Okay. Alpha into beta equal to c by a. Okay. Now substitute in this formula. Alpha is 3 by 2 into beta is minus 1 by 3 is equal to what is c here? Minus 3. Minus 3 by what is a here? 6. Okay. So 3 in the numerator minus 3. In the denominator 2 3 is 6. Equal to here also we got minus 3 by 6. So here also the LHS is equal to RHS. Hence the zeros of the polynomial are verified with the coefficients of the given polynomial, quadratic polynomial. Okay, na? Now look at the next question, bit number 4. Now look at the bit number 4. 4u square plus 8u. From this, just write down this equation as it is. 4u square plus 8u. Take 4u common here. Okay. 4u into u plus 4 2 times. So this is 2. Okay. So 4 plus 2 here. U plus 2 this one. 4u into 4u u plus 2 here. Now for the zeros of the polynomial. For the zeros. P of u equal to 0. Okay. So first make it a 4u equal to 0. Then u equal to 0 by 4. That equal to u equal to 0. Okay. One is 0. And another is u plus 2 equal to 0. Then u equal to minus 2. U equal to minus 2. So these are the zeros of the polynomial. Alpha is equal to 0 and beta is equal to minus 2. To check whether that these two are correct or not, substitute in the relationship between the coefficients and variables. So here, what are the variables here? And what are the coefficients of u value u in this quadratic equation? So a is equal to 2, a is equal to 4, b equal to 8, and c equal to 0. Okay. Now sum of zeros. Sum of zeros. That is alpha plus beta equal to minus b by a. So alpha is 0 plus beta is minus 2. And here minus b is means minus b is 8 by a is 4. Okay. So this is minus 2 equal to 4 1 is 4 8 2 times. So this is minus 2. So on LHS is equal to RHS. Okay. Now check for the product of the zeros. Product of zeros. That is alpha into beta equal to c by a. Okay. Now what is the value of alpha here? 0. 0 into beta is minus 2. Equal to what is c value? C is 0 by a. A is 4. So 0 into something is 0. Equal to 0 by something is 0. So on LHS is equal to RHS. Hence the given zero, the zeros are these are the real zeros. Okay. And here zeros are verified with their coefficients. Now look at the next bit. Now look at the bit number 5. Okay. T square minus 15. So now look at here. Then write t square is equal to 15. T square minus 15. Then for the zeros of the polynomial, p of x is equal to 0 now. Then t square minus 15 equal to 0. Then t square is equal to 15. T is equal to plus or minus under root of 15. Okay. Means one is plus 15 under root 15. Another is minus root 15. T value. So here p of t. And now check whether the given roots values of the t value are whether the with their coefficients. These are the zeros, alpha and beta. So alpha is equal to root 15 and beta is equal to minus root 15, and verify with their coefficients. Okay, na? Of the quadratic equation. Now substitute in sum of the zeros formula. Sum of zeros, alpha plus beta equal to minus b by a. Here a is equal to 1, b is equal to 0, and c is minus 15. Why b is 0 means there is no t value, t terms. Okay, there is a t square term is there, that is means a coefficient is there, that is 1, and a t square coefficient is 1, and t coefficient is 0 here, so b value is 0. And constant term is c, that is 15, minus 15. Now substitute in this equation, alpha is root 15 plus beta is minus root 15, and equal to minus 0 by 1. So root 15 minus root 15 equal to 0, and minus 15 minus root 15 and plus root 15 cancels, so 0 equal to 0. Okay, na? Now substitute in product of the zeros formula. Product of the zeros, alpha into beta equal to c by a. So what is alpha here? Root 15 into what is beta? Minus root 15. Okay, equal to what is c here? C is minus 15 divided by a is 1. So root 15 into root 15 is a root cancel, then it is 15 and the minus symbol is there. So minus 15, okay, equal to, here minus 15 by 1 means minus 15 only. Here also the product of the zeros equal on both sides, LHS and RHS. Hence the zeros are verified with their coefficients of the given quadratic polynomial. Okay, na? Now look at the next bit. Now look at the last bit of the first question. 3x square minus x minus 4. Okay. So write down 3x square minus 12x plus 1x. Maybe this is 10x, I think. So minus 10 or 11. Maybe 11x minus 12x plus 1x minus 4. Okay. So this is 11x. Then take 3 common here. 3x common. 3x into x minus 4 and minus 1 common here. Minus 1. No need of minus 1 plus 1 to x minus 4. Okay. Now x minus 4 take common on both the terms. X minus 4 into 3x plus 1. Okay. Now for the zeros of polynomial, for zeros of polynomial, p of x equal to 0, then x minus 4 equal to 0, then x is equal to 4. 3x plus 1 equal to 0, then 3x is equal to minus 1, x is equal to minus 1 by 3. These are the zeros of the polynomial. 4 alpha is equal to 4 and beta is equal to minus 1 by 3. Okay, na? Now coefficients of the equation are a is equal to 3, b is equal to minus 11, c is equal to minus 4. Substitute in the formula. All sum of the zeros. Sum of zeros, that is alpha plus beta equal to minus b by a. Okay, na? So what is alpha here? Alpha is 4. Okay, na? So 4 plus beta is minus 1 by 3 equal to minus of minus 11 by a is 3. Okay, 1 minute. So here it is, 4 3s are 12 minus 1 by 3 equal to minus of minus plus 11 by 3, and this is 12 minus 1 is 11, 11 by 3 equal to 11 by 3, hence proved. Okay, so LHS is equal to RHS. Now substitute in product of the zeros. Product of zeros, that is alpha into beta equal to c by a. So alpha is 4 and beta is minus 1 by 3, and c is minus 4 and a is 3. So here look at here. So minus 4 by 3 equal to minus 4 by 3. Hence the zeros of the polynomial are verified with their coefficients of the given quadratic polynomial. Okay, na? Now look at the question number 2. Yeah, in question number 2, look at the question. Find the quadratic polynomial in each case with the given numbers as the sum and product of the zeros respectively. Okay, na? So given numbers are sum of the zeros and product of the zeros. And so we know the formula, that is for the sum of the zeros. Sum of zeros is alpha plus beta. Okay, alpha plus beta for first problem, that is 1 by 4, and product of zeros, it is alpha into beta, that equal to minus 1. And we know that the formula to form a quadratic polynomial, k into x square minus x into sum of zeros, that is alpha plus beta, minus 1 into, or plus, we can say plus x into alpha plus beta plus constant term, na? So this is alpha into beta. Okay, na? Equal to 0. Now this substitute the values of alpha plus beta and alpha into beta. So x square plus x into minus 1 by 4 plus alpha into beta is minus 1. Now this is k into x square minus x by 4 minus 1 equal to 0. Then 4x square minus x minus 4 equal to 0. This is the quadratic polynomial. In the same way, look at the question number 2. Here substitute, here alpha plus beta is root 2 and alpha into beta is minus 1. Substitute in this, x square plus x into alpha plus beta plus alpha into beta equal to 0. Okay, so x square plus x into root 2 plus 1 by 3, okay, equal to 0. Then it is 3x square plus 3 root 2x plus 1 equal to 0. Is it correct? I think this is minus of x. Yeah, this is minus of x. Okay, so this is minus, this is minus. So 3x square minus 3 root 2x plus 1 equal to 0. This is the quadratic polynomial. Okay. Now look at the third one. Here alpha plus beta equal to 0 and alpha into beta is root 5. Now the formula is k into x square minus x into alpha plus beta plus alpha into beta equal to 0. Now k into x square minus x into alpha plus beta is 0 plus alpha into beta is root 5. Okay, equal to 0. Then here if you send this k this side it becomes 0, then x square minus x into 0 is 0 plus root 5 equal to 0. Then x square minus plus root 5 equal to 0. And this is the quadratic polynomial. Okay. Now look at the question number 4. Question number 4 is bit number 4. Question number 2, bit number 4 is 1 comma 1. Okay. Now here alpha plus beta is equal to 1 and alpha into beta is also 1. Okay. Now we know the formula, that is k into x square minus x into alpha plus beta plus alpha into beta. Okay, equal to 0. Then x square minus x into, now you send k this side and it will become 0. And x square minus x into alpha plus beta is 1 plus alpha into beta is also 1 equal to 0. Then the quadratic polynomial is x square minus x plus 1 equal to 0. Okay, and then here alpha plus beta is minus 1 by 4 and alpha into beta is 1 by 4. Then k into x square minus x into alpha plus beta plus alpha into beta equal to 0. And these are here alpha plus beta equal to minus 1 by 4. Alpha into beta equal to 1 by 4. Okay, na? Now substitute those values. X square minus x into minus 1 by 4 plus 1 by 4 equal to 0. Then 4x square minus or minus plus x and then plus 1 by 4 equal to 0. Then 4x square plus x plus 1 equal to 0 or the same. This is the quadratic polynomial. Okay. Now look at the last case. So here alpha plus beta is equal to 4 and alpha into beta equal to 1. So here x square minus x into x plus alpha plus beta plus alpha into beta. Okay, so x square minus x into alpha plus beta is 4 plus 1. So then x square minus 4x plus 1. Okay, equal to 0. You can write, okay, this is the quadratic polynomial with the given zeros. Okay, now look at the question number 3. Look at the question number 3 now. Now look at the question number 3 here. Find the quadratic polynomials for the zeros alpha and beta given in each case. So in the last problem, the sum of the zeros and product of the zeros given. And in this problem, direct values, only zeros are given. So here alpha is 2 and beta is minus 1. Okay. Now first to find out the sum of the zeros and product of the zeros, then substitute in that quadratic equation format. Okay, na? Then you will get the quadratic polynomial. So alpha plus beta, sum of zeros equal to alpha plus beta, that equal to 2 minus plus minus 1, that equal to 2 minus 1, that equal to 1. Okay, and product of zeros alpha into beta that equal to 2 into minus 1 that equal to minus 2. Okay. Now we know that format of the quadratic polynomial, that is k into x square minus x into alpha plus beta plus alpha into beta. Okay. In this format, now substitute the values of alpha plus beta and alpha into beta. So x square minus x into alpha plus beta is 1 and plus alpha into beta is minus 2. Okay, and you'll get x square minus x minus 2 is the quadratic polynomial equal to 0. Okay, now then in the second question, now here alpha is root 3 and beta is minus root 3, or you can take a reverse also, alpha this is beta and this is alpha. Okay, now look at here, sum of zeros, sum of zeros, it is alpha plus beta equal to root 3 plus minus root 3. So plus root 3 minus root 3 cancel, and sum of zeros is 0, and product of zeros alpha into beta equal to, so root 3 into minus root 3. Root 3 into root 3 is root 3 square and minus, okay, minus root 3 whole square. Square root is cancelled, then answer is minus 3. Now substitute in this format of the quadratic polynomial. So k into x square minus x into alpha plus beta plus alpha into beta. Okay, then x square, 1 minute, x square minus x into alpha plus beta is 0 plus alpha into beta is minus 3. So x square, this is 0 minus 3. So this is quadratic polynomial. Okay, now look at the bit number 3. Now bit number 3 is 1 by 4 comma 1. So here alpha is equal to, let me change the color here. So alpha is equal to 1 by 4 and beta is equal to 1. Now sum of the zeros. Sum of zeros. Alpha plus beta equal to 1. Alpha plus beta is equal to 1 by 4 plus 1. That equal to 4 plus 1. 1 plus 4 by 4. That equal to 5 by 4. Okay. Or this is minus 1. I think from the textbook this is minus 1. So this is minus 1. Okay. This is minus 4. So minus 4 plus 1 is minus 3. So minus 3 by 4. So alpha plus beta is minus 3 by 4. Okay. Then find the product of the zeros. Product of zeros, alpha into beta, that equal to 1 by 4 into minus 1, that equal to minus 1 by 4. Now substitute in that quadratic equation format. Okay, k into x square minus x into x alpha plus beta plus alpha into beta equal to 0. Then x square minus x and alpha plus beta is minus 3 by 4 plus alpha into beta is minus 1 by 4. Then you will get the in the denominator 4 is there, then 4x square plus 3x plus minus 1. Okay, this is minus, plus into minus is minus, minus 1. This is our quadratic polynomial. Okay, equal to 0. And next look at the fourth one. Alpha is equal to 1 by 2, beta is equal to 3 by 2. Sum of zeros. Alpha plus beta equal to 1 by 2 plus 3 by 2. And that is 4 by 2, that equal to 4 and yeah. Then your denominator 2 is there, then 1 plus 3, that is 4 by 2, that equal to 2. Okay na? Then product of zeros. Product of zeros alpha into beta. Okay, so that equal to 1 by 2 into 3 by 2. That equal to 1 3 is 3 and 2 2 is 4. So that is 3 by 4. Now substitute in this format, k into x square minus x into alpha plus beta plus alpha into beta. Okay, so here x square minus x into alpha plus beta is 2 plus alpha into beta is 3 by 4. Then you will get 4x square minus 8x plus 3 equal to 0, and this is our quadratic polynomial. Okay, with this the third question is over. Now look at the question number 4. Question number 4, verify that 1 minus 1 and 3 are the zeros of the cubic polynomial x cube minus 3x square minus x plus 3, and check the relationship between zeros and the coefficients. So we have to verify whether these are the zeros of the polynomial or not. That given is cubic polynomial. The given cubic polynomial is is p of x is equal to x cube minus 3x square minus x plus 3. Okay. Now substitute 1. So that is p of 1 equal to, okay, na? So p of 1 is equal to 1 cube minus 3 into 1 square minus 1 plus 3. So 1 cube is 1 minus into 1 square is 1, 3 minus 3 minus 1 plus 3. So minus 3 plus 3 cancel, minus 1 plus 1 cancel. Okay, and it is 0. Hence the p of 1 is, hence the 1 is it 0 of the polynomial. Okay, 1 is 0 of polynomial. Now verify the next one. P of minus 1 equal to, substitute minus 1 cube minus 3 into minus 1 square minus of minus 1 plus 3. Minus 1 cube is minus 1 minus into plus, this is minus 1 square is minus into minus plus, plus into minus is minus 3, minus into minus is plus 1 and plus 3. So again minus 1 plus 1 cancel, minus 3 plus 3 cancel, and it is 0. P of minus 1 is 0, means P of minus 1 is 0 of polynomial. Okay, and now check it whether 3 is a polynomial, 0 of the polynomial or not. P of 3, okay, P of 3 equal to 3 cube minus 3 into 3 square plus minus 3 plus 3. So here 3 cube, and this is 3 minus 3 into 3 square is minus 3 cube minus 3 plus 3. So plus 3 minus 3 cancel, minus 3 cube plus 3 cube cancel. Again here 0. P of 3 is 0, means 3 is a 0 of polynomial. 0 of polynomial. Okay. Now what is the next goal? Check the relationship between zeros and coefficients. Now what is the relationship between here cubic polynomial? Na? So sum of zeros. First one is sum of zeros. So for cubic, sum of zeros is alpha plus beta plus gamma. What are the alpha plus beta plus gamma here? This is alpha, this is beta, and this is gamma. So p of 1, p of minus 1, p of 3. Okay. Now 1 plus minus 1 plus 3. Okay. That equal to minus b by a. What is b here? In this quadratic equation, cubic equation, minus b is minus 3. B is minus 3. Okay. That equal to minus of minus 3 by a is 1. So here plus 1 minus 1 cancel 3. So 3 equal to plus into minus, minus into minus is plus, 3 equal to 3. Sum of zeros is correct. LHS is equal to RHS. Now substitute in product of zeros. Product of zeros. Product of zeros is equal to alpha into beta into gamma. Okay. And here is constant term by a. So that is c by a minus c by a here. Alpha is 1 into minus 1 into 3. But what is c here? C is no, not here c. This is d here. Okay. So a, b, c, d. So this is d. So minus of d is 3 by a is 1. So this is 1 into minus 1 minus 3 here, and this is also minus 3. Here also LHS is equal to RHS. Now sum of all the zeros, sum of product of zeros. Now one more condition is there for cubic. Sum of all zeros, that is alpha into beta plus beta into gamma plus gamma into alpha equal to b by a, c by a here. In this case, c by a. Okay. Alpha into beta is 1 into minus 1. Yes, beta into gamma is minus 1 into 3. Plus gamma into alpha is 3 into 1. Equal to c is minus 1 by a is 1. So minus 1 into here minus 1. This is minus 3. This is plus 3. Equal to minus 1. So this is plus 3. So plus 3 minus 3 cancel. So minus 1 equal to minus 1. So here also, from this we can say that zeros are the relationship between zeros and coefficients are verified. Okay na? So these are the zeros of the given cubic polynomial. Okay na? So with this, exercise 3.3 is over. Now for the exercise 3.4, look at the go through next video. Okay na? See in the next video. Thank you.